Yay. All right. Well, welcome to Indy Xamarin. My name is Auri Rahimzadeh. You can just call me Auri. I am also your presenter tonight. We are generally on the fourth Wednesday of every month, and we cover everything Xamarin. And we're probably not going to rename ourselves to Maui, but we'll see. Who knows how that's going to work out? Maui was pushed to spring of next year, I believe. So we've got a few months to make that decision. Um, Thank you very much to our sponsors, Sandy Solutions, Launch Fishers, mFractor, and Rev Debug. There we go. Ooh. And tonight's presentation is going to be Bluetooth and Xamarin Forms. And go figure, it's going to be presented by me. Yay! We are also brought to you by the .NET Foundation's the virtual user group. This is a pretty cool setup they've got, basically bringing together a lot of the meetups into one meetup. So it's pretty neat, pretty neat. So if you haven't checked that out, check it out. And with Indy Xamarin, we have a lot of videos on our channel. So if you take a look, like and subscribe, and all that jazz, and just check out all the videos we have. So lots of different topics. Cool. All right, I'm going to go ahead and get started here. All right, cool. We're just about to get started. Gonna go ahead and share my other screen. Boop, boop, boop. Now, if you have any questions during this, I will try to monitor all the different options we've got, or probably I'll try to monitor the chat. I'll be in full screen on my laptop, so I might not see it immediately, but I will check in and see what's going on once in a while. Feel free to unmute if you have a question and just go ahead and ask me. Not a big deal. Let me go ahead and start this. Come on, here we go. All right, hopefully everyone can see my screen. So, hello, I'm Auri Rahimzadeh, introducing myself again. I'm the Director of Software Engineering at Klipsch. We make premium audio speakers, sound bars, earphones, headphones, basically everything premium audio, we make it. It's pretty cool. So I'm often dealing in the world of connected devices and Bluetooth and BLE, and just making devices talk with each other, and with your phone. So tonight we're going to talk about just Bluetooth in general. We're going to go through a few examples of what is Bluetooth, how you can find discover more services and characteristics and so forth about various devices you have in your home. We'll go over a couple plugins. We're only going to do an example of one plugin, but there's a lot. We've got what is it, Alan Ritchie? What I'm sorry, I might have gotten your name wrong. Yes, Alan Ritchie, who actually wrote the Bluetooth, the plugin Bluetooth LE NuGet library. So I feel kind of bad because I'm showing the other Bluetooth plugin, but he's not a hater. And he's got a great product there. I've used it before, but tonight's presentation will be a little bit different. And we'll go over any questions, architectural considerations when working with Bluetooth, and we'll have plenty of time for Q&A. So ask anytime and feel free to hold your questions to the end. So what is Bluetooth? I mean, you can't really have any sort of device these days that doesn't have Bluetooth on it. Your headphones use Bluetooth Classic. We'll be talking more about Bluetooth Low Energy this evening, but your headphones generally use Bluetooth Classic. And here's just a good description. Bluetooth is a short-range wireless communication standard designed specifically for replacing wired connections in nearby peripheral devices like headsets, speakers, game controllers, mice, keyboards. And it can even be used to transfer files between devices in the same room. The latest major version is 5.0. I think it might be 5.1 and 5.2 for minor versions. But not all devices support this. The bandwidth also is not very high. So you're looking at like 1 megabit to 2 megabit. That may go up over time. I think it's slated to go up. But if you're trying to transfer data, like a large amount of data, like stream video, etc., Bluetooth is not for you. It's a short-range wireless communication standard, but it doesn't use a lot of power. But it's very good for audio streaming and data transfer of small payloads. Hold up a moment, please. You gotta go to your bed. So how come my audio sounds so good? Well, it's certainly not streaming PCM audio uncompressed. It uses like advanced audio codec. So there's a lot of cool compression techniques out there to get more bits over that small pipe. So yes, you can get high quality audio, but there is going to be a sacrifice in audio quality just generally because the bandwidth is limited. The newer versions of Bluetooth support higher bandwidth, and then you can have higher quality audio coming through. So, that's going to really help you when you're trying to get a higher fidelity. What about Bluetooth LE? I mean, I talked about Bluetooth Classic, but what's this Bluetooth LE? Oh, gotta hit someone. There we go. So Bluetooth LE, it is, well, this one talks about BLE audio as a new standard for low power audio transmission over Bluetooth, separate from Bluetooth 5 and 5.1. I think I copied and pasted the wrong thing, but Bluetooth Low Energy is a low energy interconnect, or pardon me, connection topology. So whereas Bluetooth uses more power, and generally the device is on all the time, Bluetooth Low Energy is meant to make use sipping of power, sipping of data, and not be connected at all times. So a good use for Bluetooth LE would be any sort of data transfer of small amounts of data. So like if you're just sending commands to and from a device. But that's it. That's all you need to do. Maybe you're going to do a firmware update. And it's just a small firmware update. You can use Bluetooth LE. There's a number of things you could do. But generally, if you're going to be communicating with devices these days, you're probably going to be using Bluetooth LE. But it's slow, so keep that in mind. It's like it said here, it's perfect for low power data transmission for battery powered and embedded devices. So whereas you can get 1 to 2 megabit with Bluetooth Classic, you can really only go up to around 260 kilobit with Bluetooth LE. And you may be able to get more or less depending on the device, but I would assume you're going to get 128 to 260 kilobit, and I would not expect too much out of that. But one big benefit of Bluetooth LE is that it's low power, so it sips power, so you could use it in like a Bluetooth powered remote, for example. So instead of using some custom proprietary RF technology, you can use Bluetooth LE. And it really just stops that ever-growing list of short-range RF technologies, just with a common standard that's super easy to understand and implement. So I'm just going to make sure there's no questions sitting in there. Okay, Mark's going to drop. That's okay. You can watch the recording later. So there's a few key terms that you need to understand. And I think once you understand what these are, Bluetooth and just Bluetooth LE in general, they make more sense. If you just dive into Bluetooth, it can be really confusing. Like you just expect things just to work. But if you understand the breakdown, there's a process for making things happen, and it works pretty effortlessly once you understand. So at the very top is the GAT profile, generic attribute profile. And this is like your menu of all of your services and characteristics. So think of it, like a menu or a database or what have you, whatever you want to call it. You can query to see if it's changed, although it doesn't often change. But this is everything that your device offers. And it can be queried. You can discover a device and then discover its GAT and see all of the services and characteristics. Then inside of the GAT, like I said, are services and characteristics. A service is like a parent container of characteristics. So I have a device information service. I have an audio service. I have a firmware update service. I have other custom services. The service doesn't actually provide the service. The service is a container of characteristics that you can read and write to. And you can also do notifications and so forth. I'll get into that a little bit. But the service is just an organizing structure. Then you have the characteristics under the service. So you can look at those almost like API endpoints. Like if I had a firmware update API, I may have like whack firmware, but then all the individual HTTP requests that I make would hit various characteristics like the get, the post, the put, the delete, etc. So under the service are these characteristics. And if I was in my device information service, I may ask for the device name or the device hardware revision. And I can read those details. Some are read, some are write, some are read write, some are notify or indicate. So you can be event driven. And all of these are identified, both the services and the characteristics, by UUIDs. So the funny thing about the UIDs is I would not try to hard code those. I'll get into that. You're definitely going to want to use constants there if you are working with a device that you know. Your code will just be more readable. And then you can get optional details associated with a characteristic through a descriptor. If we put a picture to it, it looks like this. So here's your GAT profile. And then you've got your service, which holds any number of characteristics. And you can have any number of services. I'm not aware of what the limitation would be, but it does take time to discover the GAT and all of its services, and then each service's characteristics. So just keep in mind if you do a very large GAT profile, I don't know, I'd just be careful how you approach utilizing it. I'll get into that. And then this is the view with descriptors, just adding that additional level. So there's a couple useful tools that you're going to use. I'm sure there's plenty more. I usually end up living in the world of NRF Connect and then using its NRF logger. NRF Connect is very cool. It finds all the devices. You can connect to them and you can issue commands. And even better, you can record those sessions like macros. And then you can replay them. So it can actually become a Bluetooth BLE server and return data or act in a certain way. It's very cool, and we'll go over that in a moment. So let's take a look at that. I'm going to go ahead and just simply share my screen. One moment. Just got to bring up my phone so you can all see it. All right. Can everyone see my screen? So we'll go find NRF Connect. And it's a free app, NRF Connect. And here you can see all the devices that it's found sitting on my network. And you can see the signal strength, etc. Hopefully everyone can see that. Yay. So let's take a look. We have I mean, anyone can do this, but I've got my Klipsch Cinema 1200 speaker right near me. So I'll go ahead and hit connect. And you'll see it has all the services. So right here, I can see the GAT. So there's a device information service right here. There's a few unknown services, which I'm sure if I looked in the documentation, I could tell you what they were, but I'm not going to. But we'll look at the device information service, and you'll find this on practically every BLE device. So we'll just click, and it will discover all the characteristics. So note that I said it will discover. So I have the GAT, I find a device. I connect to the device, and I find its services. I connect to a service, then I can read its characteristics. And as long as I'm connected to a service, I can connect to a characteristic and interoperate or interact with it. I don't get it all at once, which makes sense because remember, the key is that we're sipping data, sipping power. So there's no reason to send you all the data. It only sends you what you request. This is very important. So we can go over here and tap manufacturer name string, okay? And you'll see it returns back Klipsch group. And it's actually just manufacturer name. Not a big deal. Then model number, we can see our model number, our serial number, our firmware revision, our software revision, our hardware revision. So all of this data is now available to us. So those are the characteristics. And this is very cool. So you can disconnect. You can actually auto connect. You can do very cool things. Show your log. You can save it. You can create macros. Record what you're doing and play them back. I've actually used the macros in some beta apps. So it's kind of cool. I wrote a little XML parser and then I parse it. Let's see. So that was the example of NRF Connect. And then, of course, when you're done, you can disconnect. And you'll see I can no longer read any of these because I'm no longer connected to the device. It's just keeping all the stuff that's that I had discovered before. But because I'm disconnected, I can no longer use them. All right. We can save our session. I'm not going to. That's where NRF Logger comes in. So pretty cool stuff. I encourage you to play with this. This is a lot of fun. Just see all the devices that are around you. Sometimes I'll just go and see if I can connect to random devices and see if I can write to some things. Just to see what happens. Usually I'm not super successful on that, but it is fun. All right, cool. So we're a Xamarin group. We're talking about mobile development. So what about, how do we implement this in Xamarin? Now I'm going to go ahead and share my screen again. Hopefully everyone can still see my screen. So Bluetooth is incredibly powerful in what you can do, but the OS implementations vary so widely. There isn't a standard implementation in iOS, Android, and Windows, meaning UWP in this case, because we are a Xamarin group. So knowing those intricacies is very important. There is no built-in Bluetooth library or support in Xamarin. Xamarin Essentials doesn't offer it. Maui doesn't offer it, but of course Maui is just UI, so that makes sense. But Xamarin Essentials will help you with the permissions that are required, and we'll get into that in a moment. And there's a lot of great libraries out there, oddly with similar names. So there's plugin BLE, which is what I'm going to demonstrate some approaches tonight. And then there's also plugin Bluetooth LE, which Alan Ritchie, the developer of that, is on this call. So I'm excited to have him here. I didn't know he was coming. So Alan, I would love to catch up with you sometime and learn more. Now, getting back to the OS side, I don't know that you're going to run into a ton of gotchas. A lot of that stuff tends to be covered in these plugins documentation, thanks to their authors. But just keep in mind that if you get stuck, you should go take a look and see if there was some OS limitation. For example, with Android, I always have to make my Bluetooth calls on the main UI thread. If I don't, there could be issues. Now that could be a limitation in plugin BLE, but the way it was described to me is that it was just simply an Android limitation. And I'll get into some architectural gotchas and considerations after we do some more demos. So a big item, though, is going to be permissions, and these are very confusing because of the naming. So iOS, I think I'm trying to recall. I think it's just called Bluetooth, which is nice because it makes sense. But Android bundles all of these bundles Bluetooth into the location permission, which when you build an app that's used by thousands and thousands of users, and they see that they need to require or they need to grant the location permission, what's the first thing that they think? They think that you're tracking them, and they're paranoid about it. And so we ended up having to add a screen at one point that explained why we were asking for the location permission, because you can't rename the permission cluster. I think Android 12 separates it out. I got to check on that, but I recall checking at Google I/O, they were saying they're finally going to name Bluetooth permissions Bluetooth rather than bundling them under location. And it's been like this forever. And then Windows, I think it just depends on the library. I haven't played around much with the Windows side of it, so I don't have enough experience with that. So definitely consider your permissions and make sure that you monitor that in any app. I mean, this is true not just of here where you're using Bluetooth, but any app where permissions are required. Before you take any action that requires a permission, you should be verifying that you have that permission. Otherwise, things will go unexpectedly. So in Android, often you'll just crash because the permission wasn't granted. So Android just kills your process. In iOS, I think things simply might not work. But you need to be purposeful in your permissions and how you implement them, track them, and ensure that they are always set as expected. Now, not every platform supports all the same Bluetooth flavors. For example, iOS only supports standard Bluetooth and standard Bluetooth low energy. And if you want to do faster transfers like SPP, serial port protocol, so it's another flavor of BLE, you can't do it. It's not supported in iOS. And my understanding is you need one of their MFI chips. You need one of Apple's own chips in order to do the faster transfers. But that takes, I think, about 6 months to get certified, and you got to pay for things. It's expensive. Android supports Bluetooth, BLE, and BLE SPP for faster data transfers, where you can get like 512 kilobit and up. I've experienced that. It's not great. It's not super predictable, but it is a lot better. But it will affect you if you're transferring data like firmware updates. This will be very important for you to understand. All right, so let's take a look at plugin BLE. Not the other one. Sorry, Alan. Please forgive me. Let me see if I've got this running over here. Boop, boop, boop. See if I can find it. This is the landing page for it, Xamarin Bluetooth LE. Let me find, where'd my implementation go? There it is, BLE. I have so many. There we go. Okay, so this is the project. This is just their source code, but when you download their Git repo, you can actually get a sample client. You don't need this. It's just a NuGet package, but just letting you know, you can get the code, you can modify it. So let's take a look at what this looks like. So I'm going to go ahead and force quit NRF Connect. Leaving Bluetooth LE connections open, Bluetooth connections open, etc., can cause some trouble. So be very careful or be very cognizant of what connections you have open, and make sure you disconnect when you can. If you don't need the connection, don't waste the battery. Even if it's plugged in and you don't need the connection, disconnect. All right, let's see. Oop. I think it's BLE Explorer. So this is the cool tool that they give you. You can scan for devices. You can even use Android Auto Connect, which is like it's a quick connect. Here you can see all the devices near me. So pretty cool stuff. I can tap and then I can copy the GUID of the device, or I can connect to it. I'll say, are you sure you want to connect? I'll be like, sure. And it'll connect. And now it'll show me all the services. And I can click in and see all the characteristics. I'm not sure if it'll let me read the string. There we go. So here we go. We can look at the details, read permissions, what its current value is. If I hit read, it'll return the data, which this actually ends up being 10144. You're going to get very familiar with bit converter. You can't update it, but you can take a look and look at the descriptors if there are any. There are none here. But here you go. We connected to the device. You can say update RSSI. So you can just update the GET. You can show the services. So remember, connect, then services, then choose a service and connect to it, and you'll get all the characteristics if you scan for them. You don't have to scan. Scanning takes time, which means it uses energy. So if you already know the GUID, see all the GUIDs here, then you can connect directly to a characteristic after connecting to a service. And then you can just read it. So once you have the characteristic GUID, or it's not GUID, it's not a GUID, it's a UID, sorry. You can just read it and you're all set. And you can subscribe to updates, and you can unsubscribe to updates. So not only can you read and write, you can also be notified. So this makes sense. You can actually have an event-based system. So, for example, like headphones, if the user changes the volume on the headphone, you shouldn't have to poll to find out what the current volume is. You should be notified when the volume has changed, so you can update your UI. So that's where you would subscribe to notifications. And it all depends. Not everything can have a notification. But this is free, as Alan's is as well, and it has this cool little MVVM cross. app that you can play with. I'm not an MVVM cross guy, but yeah, you could go either way. So I took a different approach. I didn't use their MVVM cross approach. So pretty cool. All right. Back to the presentation. So architecturally, how should you approach this? So the story of how I got involved with building my own BLE app, because I work on a lot of apps. I help make those happen, but I'm not usually the one writing the code. Just because I'm more on the management side of it, but I often do like to dive in. And so we had a device that needed to add a remote control. And I had been told that all of the GAT had been implemented. So I had a list of the GAT with its services and its characteristics. Like you could get and set the volume, you could get and set the EQ, things like that. But no one knew if it worked or not. Because it had been done like a year prior. I'm like, well, but let's write a test harness. So while working on a plane and sitting in an Amex lounge just on a day trip, I wrote this app to talk with our sound bars and our headphones, etc., but specifically one of our other products. And make it do things. So it was a good time. It was my first time really diving into BLE, because everyone talked about it, but I had never had to actually write anything. So I was like, cool. And so I wrote it, and a few hours later, I had something working. I chose that plugin BLE. And then I fine-tuned it over the course of another day or two, and kind of came up with my own patterns and ideas of how I want to approach things. And it seemed to work pretty well. So my initial approach was just simply to reference the NuGet package from the iOS and the Android apps, and then also the Xamarin.forms app, or the Xamarin.forms project. And I was able to just make everything work. I modified some of the sample code, but then I wrote my own Bluetooth service and a handler. And it worked out pretty well. So just kind of building my own service, and then just working with it. But what I didn't do, which in hindsight could have been better, was build my own implementation in iOS and Android and eventually Windows, and just inject using either an IOC container or the built-in Xamarin dependency service, inject my Bluetooth instance. So that way I can support any number of different operating systems. And that's when I found out that like plugin BLE doesn't officially support UWP apps. They have a branch, but it just doesn't work that well. But it's for an older version of Windows 10. So I've been thinking about rewriting it so that I could just use DI to inject. But because the interfaces really aren't super easy to abstract, I've run into some I'm worried about some jankiness around it. So I'm looking at some possible other approaches. So like I said, what I did was make things work. It works well. And I just used the already provided platforms. There were a few other things that I learned architecturally. Assume you'll get disconnected. You could get disconnected for any reason. The battery ran out. They have headphones, but they only have one headphone out of the case at the time. Like you may assume that they have both out, and they put one back in. They turned airplane mode on. They left them in another room. They walked away from them. Your app needs to assume that it can lose the connection at any time. And you should take that into account. And I believe both libraries support detecting connection state and being notified when connection state has changed. So be purposeful on that. And also think how users will use your device, whether it's plugged in or battery powered. Think about how they're going to use it. Like getting back to that example of the headphones. Um, if a user, I don't know if you can see my video, but if a user takes one earbud out, but not the other one, they're expecting that audio will still work, but not both earbuds are out. So you need to take that into account. The same thing goes for what if another Bluetooth device wants to connect? How many devices will you support? There's a lot you need to take into account, and if you're not purposeful about it, the experience will just be bad, and at the same time, you won't have coded defensively enough to keep your app reliable, stable. And perhaps one of the things that goes without saying is you need to think asynchronously. Nothing happens instantly when you deal with networks. It's all asynchronous. You make a request, you get a response. But you may make a request and get a response later. So if you're not familiar with the async and await patterns, or reactive, if you want to use like plugin.bluetooth LE, you need to get familiar with thinking asynchronously, because whenever you're dealing with communications, it's all async. And you will be punished by the operating systems for not doing things asynchronously. If you lock the thread, within 7 seconds, iOS will just kill your process. And Android may just randomly kill your process, going, you're doing too much on the UI thread. You're making this experience terrible. I've killed you. That's it. Goodbye. No more process. So be very aware of thinking asynchronously. So a little bit about my approach. I tried to make things relatively simple. It was like the same pattern at all times. So I created my own little BLE utility, and then everything became pretty simple. So ignore my logger. I always make sure that my device is connected. If it's not connected, I throw a device not connected exception that I can respond to over in the parent. This is all in my service. I go and I get the data back. So I just wrote a cool little BLE utility that runs a read command. I pass it the device, and then I just know my UIDs. See how I just put these all in constants? I just have a class that has some UIDs. That's all. Very simple, but the code is very readable. So I pass in the service name, because remember, you have to connect to the device, then the service, then the characteristic. So I make sure I'm connected, as you can see, and then I pass in the service and the characteristic. I get the data back. If I get data that's not what I'm expecting, I pad the bytes. I wrote a little pad bytes function. And then in this case, I know that I get int back. See, int. And I say result bit converter 2int16. I convert it. I log it, because this was just a harness app. It wasn't an app that I would ever release to production. And then I just return the result. Notice that it's an async task that returns an int. Same thing here, task bool, set master volume. So just true or false, were you able to successfully set the volume? I do the same thing, ensure the device is connected. I write the byte array. I get the result, and then I return the result. Now, what is this BLE utility? So the BLE utility is super simple. So I pass in the device, the service UID, the characteristic UID, and my logger. And then I get the service async. Remember, I have to connect. I have to get the service and then the characteristic. Remember that. Connect to the device, get the service, get the characteristic, and now you can do things. If you don't connect to the service first and you try getting the characteristic, you'll get that the characteristic doesn't exist because you're not connected to a service. So follow this pattern. Things generally work out well. So I get the service, I get the characteristic, and then I just get the data back. Bytes, read async, and I return my bytes. For writing, it's also very simple. The device, service ID, the characteristic ID, the data to write, that's just a byte array. And here's the same pattern. Service, get the service. Then get the characteristic. And then I make sure that I run this on the main thread. So main thread.invoke on main thread async. And I write. I get the data back and I return the result for whatever the calling service wants to do with the result. So this made things very simple. I can read and I can write very easily. Now, there's some gotchas here. Like I said, very important. Connect to the service first, then you can read the characteristics. I suggest you only connect to one BLE device at a time. Always check your connection status before accessing a service or a characteristic. I would hard code your services and characteristic UIDs if you know what they are. I mean, if you're writing a Bluetooth scanning app, BLE scanning app, fine. But I don't think that's what you're generally going to build. I think you'll scan for the devices that are around you and read their device information service characteristics and find out if it's a device that you need to connect to. So is this, for example, Klipsch, is it a Klipsch device? Is it the model number that I need? I could scan all the devices in my vicinity and they all generally have that device information service. So I can just make sure that I only surface the Klipsch devices in my app. Pretty simple. Once you start getting the data. And if you keep the UIDs in friendly names, you'll understand your code so much better. No one knows your UIDs. Use constants. Make very friendly names for all this. Now, make sure you disconnect if you no longer need the connection. Respect the battery. And if you know the UIDs already, don't scan for services. It's a waste of time and battery. There's no reason to discover the services and their characteristics if you already know them. Now, you can check whether a service exists, like maybe you connected to the wrong device. But every time you connect to a device, you shouldn't be scanning for what it has unless you need that. It'll just make your app slower. It adds room for error, and it wastes battery life. It makes things slow. I mean, don't waste time. So that's a lot of information. If you want to learn more, you can get NRF Connect pretty easily. Just like go get it in Google Play. I'm an Android guy. Bluetooth SIG, if you want to stay on top of everything happening Bluetooth and Bluetooth Low Energy, which the Bluetooth SIG manages, go to the Bluetooth SIG. I think it's bluetooth.org, but you just search Bluetooth SIG. There's plug-in Bluetooth LE. So Alan's page does a fantastic job of explaining the GAT, the services, the characteristics, and what they all mean and how this all comes together. So kudos to Alan for such a great write-up. I put a little bit.ly here so you don't have to type everything up. And then, of course, the plugin BLE page has a sample app. So you could always play with this, whether you're just using standard Xamarin Forms or MVVM Cross, or if you're a reactive developer, you can use plugin.bluetooth.le. Alan mentioned Shiny, which I have not used, but I've heard of. And thank you very much. Do you have any questions? Questions? Alan is typing. Hey, thanks, Alan. We'll have to connect on LinkedIn. I want to learn more from you. Any questions, anyone? Feel free to unmute. Thanks, Nick. Oh, cool. Thanks, Dave. Thanks, Keith. I'm going to stop recording since it doesn't sound like anyone has any questions. So I hope you enjoyed this presentation. Like and subscribe and all that jazz.